Good morning, dear students. Welcome again. Today I am going to continue my chemical kinetics lesson with the help of mechanism of the reaction. Two types of chemical reactions are possible. The first one, simple reactions, and the second one called complex reactions. If reactions are simple in nature, simple reactions are also known as elementary reactions. Then rate can be determined with the help of stoichiometric coefficient of the reactant. So we can write what? Our heading is mechanism of a reaction. Two types of reactions are possible. First one, elementary reactions, or you can say simple reactions. Such reactions always proceed in single step. So we can write those reactions which completes in single step and which have exponents in rate law equal to stoichiometric coefficient of the reactants. Consider following general chemical reaction, that is here a small a and a small b are called what? A stoichiometric coefficient of reactant A and B. Therefore, rate is equal to K, capital A का concentration, power small a, concentration B, power B. This is said to be what? Rate law for this chemical reaction. Two important points always remembered. First one, zero order reactions can never be elementary reaction. Second one, elementary reaction for elementary reactions, fractional order become not possible. It always remember, elementary reactions, fractional order become not possible. Order of reaction for such type of reaction become always a whole number. Our second reaction is complex reactions. Those reactions which proceeds more than one steps. If more than one steps are involved in the reactions, then slow step determine the rate law. So the second one, our reaction become complex reactions. We can write what? Those reactions which complete and multi-step. For such type of reactions, mechanisms become possible in rate law expression rate of reaction depends upon the concentration of reactants of slowest step which must be free from intermediate. It means such type of reactions, the mechanisms become possible. Mechanism means how our chemical reaction become proceed. Let us consider following reaction, that is 2NO2Cl after heating to produce 2NO2 plus Cl2. If mechanism of above reaction is given, that is first NO2Cl converted into NO2 plus Cl free radical. It is said to be slow state reaction. And the second one, NO2Cl gain chlorine free radical converted into NO2 plus Cl2. This is fast state. After adding A and B, we obtained our original reaction. A is said to be slow state. Therefore, rate law, that is dx upon dt is equal to k NO2Cl. The stoichiometric coefficient involved in slow state determine what? Rate of reaction. So in nutshell, we can say slow state is the rate determining state in complex pattern of reaction. We can draw the graph between energy and progress of reaction. That is, suppose in this axis, if we take energy and horizontal, we can write progress of reaction. Such are said to be what? Transition state. This is called what? Intermediate. So if intermediate is possible, then we can draw the mechanism of such pattern of reaction. Consider following reaction, that is 2NO plus 2S2 gives N2 plus 2S2. Suppose the following pattern of reaction mechanisms are given, that is 2NO converted into N2O2, and the second one N2O2 plus S2 gives S2O plus N2. Suppose this is said to be slow state. And the third one, N2O plus S2 gives N2 plus water. Suppose it is said to be fast state. If we added such equation, then our original equation become obtained. Equation second is said to be slow state. Therefore, rate is equal to what? K N2O2 S2. It means order of reaction is equal to what? 1 plus 1 is equal to 2. But a equilibrium reaction is also given. So from equation first, we can write what? Suppose equilibrium constant is K dash N2O2 divided by NO square. This is according to law of mass action at the stage of an equilibrium. So concentration of N2O2 is equal to what? K dash NO square. putting the value of N2O in this expression, therefore rate is equal to what? K dash N2O2. Instead of N2O2 we can write NO square and S2. K and K dash are called what? Constant. Therefore rate is equal to K double dash NO square S2. K double dash is new constant. So from this relation it is clear the derived rate law is agree with experimental rate law. The derived, suppose this is equation A, this one equation B. From equation B we can write this is derived rate law agree with experimental rate law. One thing always remember, for complex pattern of reaction, order of reaction can be 0, maybe gives fractional value, or sometime negative in nature. Our next important heading is molecularity. First, we have to understand the concept of molecularity and characteristic of molecularity. The actual number of molecules, ions, or you can say atom, take part in single step reaction is called what? It's molecularity. Molecularity is a theoretical concept. When mechanism of the reaction is given, then you can find out molecularity. Molecularity is always a whole number. Molecularity never be 0. Not gives fractional value. For complex reactions, the additive molecularity is not possible. It becomes meaningless. Molecularity never be greater than 4, or you can say equal to 4. Molecularity is free from temperature and pressure. So we can write what? Total number of molecules, atoms or ions participating in an elementary reaction is called as molecularity of reaction. Some important points. It is a theoretical concept. Second one, molecularity can be an integer but cannot be 0 or negative or fractional in nature. Next one, in an elementary reactions, molecularity is equal to generally order of reaction. Total molecularity of complex reactions become meaningless Next one we can write molecularity is free from temperature and pressure. In last you can write what? Molecularity greater than equal to 4 are rare. Such are the characteristics of what? Molecularity. One important question, always remember what are the difference between molecularity and order of reaction. The most important difference is order of reaction is an experimental fact, whereas molecularity is a theoretical concept. Order can be determined with the help of rate expression, but molecularity, when mechanism is given, then we can find out. Order of reaction may be 0, maybe gives fractional value, sometimes gives negative value, but molecularity can be an integer, but cannot be 0 or negative or fractional in nature. So that are the major difference between molecularity and order of reaction. Consider following complex reaction. That is 4HBr plus O2 gives 2H2O plus 2Br. From above equation it is clear this reaction is complex in nature, because the sum of stoichiometry concept, the sum of stoichiometry for this reaction is equal to 4 plus 1 is equal to 5. So several steps are possible in such reactions. Consider mechanism of above reaction. First, HBr plus O2 HCHOOBr. Second, HOOBr plus HBr gives 2HOBr. Third, H2Br plus HBr gives H2O plus Br. If we add such equation, we obtained our original chemical reaction. So for complex reaction, each step have got its own molecularity. Molecularity of each step become equal to 2. Why? Because 2 mole of reactants involved in each step. So for complex reactions, if mechanisms are given, then we can find out the molecularity of the reaction. Our next important term is pseudo first order reaction, or you can say pseudo unimolecular reaction. Pseudo first order reaction. Such reactions in which the order of reaction is equal to 1 and molecularity is not said to be 1, or you can say molecularity and order become different. Generally order is 1, then molecularity become 2. Such pattern of reactions are called what? Pseudo unimolecular reactions. Generally hydrolysis reactions are the example of pseudo first order. So we can write a chemical reaction in which value of order of reaction is 1, but molecularity is more than 1. Are known as pseudo first order reaction, or you can say pseudo unimolecular reaction. Consider following hydrolysis reaction. That is, if we take any ester like ethyl acetate plus water in presence of acid, form CH3COOH plus C2H5OH. This is hydrolysis reaction. If rate is equal to K CH3COO C2H5 per power 1 water per power Z. Therefore order of reaction is equal to what? 1. Why we take the power of concentration term in water is equal to 0? Because the concentration of water do not vary with respect to time. That is, concentration of water is always uniform. That's why the power become equal to what? 0. In this reaction, order of reaction 1, molecularity is equal to 2. Because both molecules take part in chemical reaction. That's why molecularity become equal to what? 2. So here molecularity and order is not become similar. Order is 1 where molecularity is 2, then such pattern of reactions are called first order reaction, or you can say pseudo unimolecular reaction. Generally, hydrolysis reactions are the example of such pattern of reaction. Okay, so in next lecture we will see first order reactions in terms of pressure and numerical based upon such type of concept. Thank you.